If you break into this parallel universe, discover yourself in this universe, live better than you, what will you do? The heroine chose to kill herself. Live in this universe on your behalf. This is a movie about parallel universes, and in recent years, more and more movies started to reference the concept of parallel universes. You have more or less heard of quantum mechanics. It sounds like a very high and inscrutable word. Have you tried watching videos related to quantum mechanics? But it's hard to hold on. Today, I will tell a story. Take everyone to get started from scratch and touch it. Finally, the parallel universe is the ending point. After less than an hour of viewing, not only will you appreciate scientific principles of the most advanced research in modern science, we'll also explore and caress human beings. In the process of exploring the truth, the spirit of unremitting pursuit demonstrated. Chapter 1. I choose to start with the light that illuminates the world. Time comes to the European continent in the 16th century. This is a Christian world. People living in difficulties. After finishing farm work or in leisure time, I would go to a nearby church to listen to the priest telling stories. At that time, the stories in the scriptures are a way for the public to acquire knowledge. The only way to understand the world. The Taoist God in the book said that there must be light. So there is light. Light is God's creation. It symbolizes the sacred, holy, beautiful, righteous, gracious, and a ray of sunshine in the darkness. It will bring a sense of hope to people. People will subjectively interpret that to mean that God does not abandon me and the rainbow across the sky. In their stories, it was Noah and his family who escaped the great flood. The testimony of the deity's name and the contract between the stars and the moon. The rainbow represents God's promise. I will never send a big flood to wipe out mankind again. And for thousands of years, people's understanding of light. Visions that stay on this kind of spiritual level. Until the Renaissance, religious reform. The Enlightenment inspired human ego and rationality. Groups of seekers after groups. To gain more knowledge, they began to explore various ways. Then some people continue to search spiritually, and some turn their attention to the material level. The most well-known of them was born in 1643, the world's greatest physicist Isaac Newton. Newton was a Christian, but he is a heretic, if we describe it according to his tone. He lived a poor life. What I want to explore is how to understand God's world. For example, he believes the manipulator behind gravity is a god. What about his personal beliefs? That's another topic. And when he was only 23 years old, discovered the connection between light and rainbows. Let's come to the next section, colorful light. In 1666, Newton conducted an experiment. He passed sunlight through a prism. Turn out, pure white light was broken down into bright and beautiful red, orange, yellow, green, blue, purple. Isn't this a rainbow? It turns out that sunlight can be decomposed. Decomposed light. It's called monochromatic light. In turn, the daylight we see. It's actually a mixture of all the colors of light. It's compounded. This explains it. Phenomenon that we can observe with the naked eye every day. For example, the sun rises from the east. At this time, the sun's rays will reach your eyes. It has to pass through a thick layer of atmosphere, but different colors of light. Its penetration is different. For example, the following part. The light penetration in the blue range is relatively weak. So, when they encounter particulate matter in the atmosphere, its direction will change at different angles. The longer the distance through the atmosphere, the more blue light the direction is changed, until the end. Almost no blue light reaches our eyes anymore. The light in the red range has strong penetrating power, not easily redirected, at last. Only this part of the light reaches our eyes. So we see the rising sun as a red sun. It's redder when the sun is halfway up. Sunlight becomes thinner as it passes through the atmosphere. This means, gradually some blue light can reach our eyes. So the red color is neutralized. Start leaning towards yellow. So we see the sun starting to turn yellow. It's noon. The sun is high overhead. The atmosphere through which sunlight passes is the thinnest. It means that there is enough blue light at this time can reach our eyes. What color does all monochromatic light have when combined? That is the original white light. So the sun at noon is so bright that it looks white. That is daytime. At this time, if it is in a later time zone, there's a man up. He saw that the sun was red. Have you ever thought about why is the sky blue, but in space, the sky is black? Still the same reason. Blue light penetration is weak. While passing through the atmosphere, they kept crackling and changing direction. This is the scattering of light. You roughly understand it as the atmosphere traps a lot of blue light, but the penetrating power of red light is too strong. He can't hold it, so we see the blue sky. It's the atmosphere that traps the blue light. Once you're in space, no more atmosphere. Only deep black remains around. The principle of rainbow formation. They are the small water droplets left in the air after the rain, equivalent to a prism. Refract light of various colors at different angles, so daylight is broken up across the sky, seen by us. This is the principal relationship between the two. Let's summarize. After Newton's time, people's understanding of light has deepened. Originally, we could only see the surface. The sun shines on the earth. Now we realize. It turns out that it is the result of the combination of light of multiple colors. So what are Newton's academic contributions? 3 or 2 sentences are enough to praise you. But what I always have to mention is, in the spirit of human understanding of history, he and many scientists formed a force, created a rationally based environment for acquiring knowledge. This environment is called the scientific age, and among them batches of seekers of knowledge came to him, took over the baton from Newton, continued to promote the entire human civilization, moved towards more knowledge. At the same time, people's understanding of light has also improved to a higher level, and it's still very high. Let's go to the next section. Light oscillating up and down. Light is an intangible thing. You can't touch it. To understand and study it, it is understandable that the difficulty is great, and in the age of science, ingenious experiments designed by various physicists, proving a new understanding of light. For example, they understand the form of light propagation, like a wave, up and down, up and down. Such a trembling wave. People also calculate the speed of light traveling in vacuum is a fixed constant, about 300,000 kilometers per second. We also learned more about electricity. It was also discovered that magnetism around magnets. Is there a connection with electricity? What cuts magnetic field lines? High school knowledge that can produce electricity. And one of the most significant scientific discoveries. It was in 1865. The theory of electromagnetic fields studied by physicist Mike Sewell. At that time, he deduced that in space, there is something. This thing is a vibrating wave. And this kind of wave, it has the properties of electricity. Net oscillation also has magnetic properties. Net oscillation. The two form a 90-degree right angle. Common shock. Let's go hand in hand, almost like this. How do you name something like this? Then call it electromagnetic wave. Although this is just a theory. But there are exciting discoveries. Because there are so many coincidences. What a coincidence! He unexpectedly figured out. The speed of electromagnetic waves is almost the same as the speed of light. You can set the speed of so many things. The miraculous craftsmanship of nature. Why did you choose 300,000 kilometers per second? There can't be such a coincidence. So he speculated. Light is this type of oscillating electromagnetic wave. As expected, just 20 years later, experimentally, Hertz confirmed his suspicion. The existence of electromagnetic waves was detected. Here, I will directly put a more intuitive one for him. Demonstration of electromagnetic waves. This is a complex device. Where is this thing? It's electromagnetic. We don't need to know much about magnetism to generate electricity anyway. Anyway, it can produce electromagnetic waves. There is a receiver on the left side of the video. When he receives electromagnetic waves, the speaker above will simulate a sound. Tell the audience that he received electromagnetic waves. There is also a light bulb above. When he lights up, it is also to tell everyone intuitively. The device has received a signal. You can see the way it's coming from there. I can cut them off with my head. Let's change the angle again. When turning this receiver one direction, we can't hear reception anymore, because electromagnetic waves propagate in straight lines. Can't turn. But we can use a metal aluminum plate to reflect. Change its direction. When rotated to a certain angle, when the receiver receives the signal again, there it is used as a reflection. It's very sharp. Then how do you know that electromagnetic waves oscillate? This shock, it's based on a horizontal line. Up and down, up and down. So shocking. Prague is on the horizon of electromagnetic waves. Move this receiver manually. Once it reaches the level point, the receiver won't light up or sound. As soon as it reaches the place where it vibrates, it will be bright and loud. This is a legitimate electromagnetic wave, although we can't see it with the naked eye. But it can be visually revealed through equipment. The above is based on our electromagnetic laws, artificially generated electromagnetic waves. And in the 19th century, as more electromagnetic waves are discovered in nature, after careful induction and summary, people realized that first, light is such an electromagnetic wave. The biggest difference between second light and other electromagnetic waves is that we can detect it with the naked eye. We can't do anything else. The largest source of electromagnetic waves is the sun. Sunlight follows the order of red, orange, yellow, green, blue, and violet. Further to the left, we can't see it. Red light, like electromagnetic waves, are called infrared rays. Other electromagnetic waves include microwaves and radio waves. The neighbor to the right of purple light is ultraviolet light. And X-rays and gamma rays. They are all in the same group. We can't see these. This picture also shows a truth. The progress of science and technology is based on the progress of basic theories. Originally, people only knew light. Use it for lighting. Later, people recognized other electromagnetic waves and learned to apply them. Infrared rays can be used for remote control. Microwave. The principle is to emit electromagnetic waves to quickly heat food. Radar communications. Navigation for driving is the application of radio waves. UV rays can be used to disinfect. Modern people have become more aware. We use sunscreen to protect ourselves from the sun. UV rays to protect skin. Medical imaging doesn't require cutting open your body. No need to open your bag at airport security. Gamma rays could be used in radioactive medicine. Then the story of God saying, "Let there be light." Now it's detailed like this. First, the sun irradiates electromagnetic waves to the earth and the human species. The naked eye can only perceive this part of it. So since ancient times, we who acquire knowledge through our senses and experience, I can only realize that it is this kind of thing that lights up the world. So in the creation stories of all human races, various literary works, poetry and drama, it is sung by us, we call it light. Until the 19th century, when scientific rational reasoning and deduction enable us to obtain knowledge beyond the limits of the senses and common sense, we recognize the things we cannot see, such as electromagnetic waves. And for some species, for example, snake, it is this part of the electromagnetic wave that lights up their world. For them, infrared is visible light. To summarize the content of Chapter 1, from the end of the Middle Ages to the 19th century, people's understanding of light is becoming more and more detailed, gained more knowledge. The picture succinctly shows that sentence. Knowledge is power. See now. Do you think the study of light is over? At least in the 20th century. Some scientists have this foreboding feeling, because at that time all branches of physics were blooming. Theory advances very quickly. At a lecture in London in 1900, British physicist Kelvin, that famous metaphor, "This is probably what we say in physics. Development has almost come to an end. There are only two dark clouds floating in the sky. Solve these two problems. Physics can be said to be 100% complete. And one of them, it's related to the electromagnetic waves we just talked about. Although in childhood, this problem, it was immediately solved by German physicist Max Planck. But when he wipes away this dark cloud, I thought it would take us to the end of the oasis in the fog, taking a step forward. As a result, we found that the oasis was further away from us, because what is covered by dark clouds It is actually a loophole in contemporary physics. And this loophole, forcing us to take a new physical perspective, to see the natural world. At the same time, it also includes re-examining our understanding of light. Chapter 2, The Birth of Quantum. Section 1, Kelvin's Dark Clouds. In this section, let's take a look at Kelvin's dark clouds. What problem does it probably refer to? First, is the frequency of wave vibration. We have been so isolated since we were little. The frequency is how fast it vibrates up and down. It's buzzing on the left. The further you go to the right, the buzz is. Waves also have another characteristic called wavelength. Wave on the left, it appears wider. It keeps repeating an up-down pattern. The repeated straight line distance is the wavelength. Straight line distance from highest point. This is more intuitive. Right, it appears narrower. Wavelength shorter than. It is the two concepts of frequency and wavelength. For example, let's talk about large 5 grams mobile phones. What are the sanctions and gaming of 5 grams technology? You may also receive telemarketing calls. Let you apply for 5 grams package refers to which electromagnetic wave do you want to use as a mobile phone signal? The frequency of electromagnetic waves used by 4 grams mobile phones is relatively slow. Buzz, buzz, buzz. Its waves look wide. 5 grams mobile phones use electromagnetic wave frequencies that are relatively fast. Buzz, buzz. Its waves appear narrow. And technology companies, to apply different electromagnetic waves to life, it is necessary to overcome many technical difficulties. To overcome technical difficulties, first, it is necessary to have considerable support and understanding of electromagnetic waves. And this knowledge, it started to accumulate at the end of the 19th century. Physics gurus study electromagnetic waves. They simulated a castrated version of the sun. It is a heated hollow metal block. A hole is drilled out of the metal block. Then they collect the light that escapes from the hole. Light is electromagnetic wave. Look at the two pictures on the left and right. Exactly the same. Then they measure the energy of the electromagnetic waves in the hole. For example, the wavelength of purple light is so long. The corresponding energy is so high. Mark a point. Then test the green light. The wavelength is so long. The energy is so high. Mark it, just like this, point by point. Finally, a line of relationship is presented. The data collected by experimental physicists. Then next, it's the theoretical physicists' turn. They are going to come up with a theoretical formula. Express the relationship between electromagnetic wavelength and energy. If this formula can perfectly reproduce the experimental data, that means this formula is a good summary. The weird thing is, no matter how to deduce, apply all knowledge of contemporary physics, or we can only introduce this kind of. The paragraph on the left is consistent with the experimental data. But when you get to the right, you can't get it right. The error is too big. Either this, the right side can match. The left side doesn't match up. What's even more outrageous is the green one. Further to the left is the ultraviolet part. The electromagnetic wave energy calculated by it. It has already exploded into the sky. What's even more outrageous is that this was already the most authoritative and cutting-edge summary at the time. And this vastly different error, called a UV catastrophe by scientists, terrible, obviously not in line with reality. All formulas and deductions in contemporary physics are used. We just can summarize the energy laws of electromagnetic waves. This is what Kelvin described. A dark cloud floating in the foggy sky. To summarize this section, if you point to, just like this, you wouldn't realize that you still have these problems. The picture also shows a truth in a simple way. Throughout the ages, in any field, when we know more, the more problems we have. The doubts become deeper. The more we realize how ignorant we are. As physicists in the 19th century learned more about light, but they found that the less they understood light. And in the same year, German physicist Max Planck put forward a wild hypothesis. Wiped away this dark cloud and this rub. Unexpectedly, I discovered quantum mechanics. Let's go to the next section, Planck's hypothesis. Hypothesis is the transliteration of hypothesis. How did Planck solve this problem? First, let's outline the overall situation of contemporary physics. Newton's scientific contributions in the 17th century were considerable. Created a matrix and a paradigm. Created a definition system definition framework. Since then almost any physical formula has been derived. If we trace the origin, are inseparable from Newton's three laws. Newton's laws are so perfect, and it is through the theoretical knowledge of this bureau that we to know the world so naturally. The starting point for all scientists' thinking, all within this system. So now we have to solve the physics problem. There are only two ideas. Either the current cognitive system has not been developed to its extreme. We don't know enough. So just follow the path paved by those who came before you. Keep exploring. We will definitely be able to solve and improve this physical system. Either the current cognitive system was wrong from the beginning, causing our formula to ebb. I've been wrong all the way from the beginning. This situation, not possible. Numerous experiments and theories have confirmed Newtonian mechanics correctness. It's seamless. However, just when people are puzzled, don't know where to start. In 1900, Planck made a bold attempt. He made a hypothesis, but his hypothesis deviated from the original system, so contradictory and conflicting with contemporary cognition. But it perfectly solves the ultraviolet disaster. What a conflict of laws. In contemporary systems, we think of energy as continuous. For example, if you go to the gym, burn calories, you consume from 20 calories to 80 calories. This process of increasing physical quantities is continuous. In our lives, almost all physical quantities are continuous. Length, temperature, mass, speed. You can take any value for these physical quantities. Any value is meaningful, but we counter for paper. 1 sheet, 2 sheets, 3 sheets, 4 sheets, and 5 sheets of paper. 1, 2, 3 for cars. 1, 2, 3, 4, 5 people. Look at these cars. Its numerical characteristic is that if it is to be increased, click and jump directly to 2. Values between 1 and 2 are meaningless. These values do not exist because there are no 1 point to people, 1.5 people. In physical terms, the feature on the left is called continuous. The feature on the right is called discontinuous. Intermittent, disconnected, fragmented. Then everyone assumes that energy is continuous. Planck proposed that when electromagnetic waves propagate, his energy is discontinuous, is broken, one by one. Based on this assumption, he brought mathematical formulas into the derivation. He actually reproduced the experimental data perfectly, summarizes the relationship between energy, wavelength, etc. UV disaster solved. You still have to take a look at the formula, but its assumptions are bizarre. Has no practical significance. It's like you suddenly said, the quantity length is intermittent. 2 for 6/8 centimeters does not exist. What does 2 for 6/8 centimeters mean that it does not exist? Too abstract, if you don't understand. Never mind that when Planck was deriving the formula, that level of difficulty is too great. He doesn't care about any practical significance, so he couldn't figure out what it meant. Anyway, the answer is right. Since the big guys don't understand, so we don't understand, this is necessary. The hypothetical process of quantifying energy. Just like the continuous flow of water in a river. Put in a cup, divide it into discrete cups. A glass of water, we say a cup of water. A piece of paper, that energy. How can I say that there has never been such a concept? This quantifier does not exist. Planck will build one. Energy. It's called a quantum of energy. And this quantum is the quantifier. It is a specific quantum unit. Planck describes electromagnetic wave propagation type. Energy is measured in units of. So, quantum and molecules, atoms, electrons, etc. Not a category. So although this is an assumption, but since the answer is right, it probably means that in objective nature, there must be some kind of pattern, not discovered by humans, and this pattern, probably beyond the scope of contemporary physics understanding, because contemporary physics can't even write the correct answer. That is to say, this kind of law is waiting for mankind to reveal, and the revealer, it will be after 5 years. Also temporarily separated from the Newtonian mechanical system. the world's greatest physicist. And what conclusion did Einstein draw from quantum? What face of nature will he reveal to mankind? And has our understanding of light reached its end? Great scientists, how to leverage the inherent cognitive habits of human beings. When light hits a metal surface, it will knock out the electrons from the metal. When typed electrons move, a current is formed. So there's electricity. This natural phenomenon is called the photoelectric effect. You can see it in many corners of the city. Its application is these solar panels. So the photoelectric phenomenon was first discovered by Hertz. But in the past 20 years, no one has been able to answer the principle behind it. Why can light knock out electrons? Until 1905, Einstein published this paper, gave his explanation. His photoelectric effect is at the mass level, not as famous as his theory of relativity. But what I want to point out is that this paper, it's not just as simple as explaining a phenomenon. More importantly, Planck's quantum hypothesis provides practical meaning and triggered a scientific revolution in human history. Chapter 2. Let's take a look. How did Einstein explain the photoelectric effect? And why this drove the birth of quantum? The photoelectric effect is very abstract. We need to use instruments to make these electrons visible first. I wiped my hair with a balloon first. Then he scraped the balloon against the metal block on the table. The needle below actually moved. This is because of the principle of frictional electrification, causing some electrons to move to the balloon. When rubbing the balloon against the metal block, the extra electrons will run to the metal block. The entire metal device becomes negatively charged. Because of the principle of repulsion, excess electrons create repulsive forces. So the metal needle was pushed away. Then when you put your hand on the metal block, the pointer will be reset. This is because humans are conductors of electricity, and the excess electrons will pass through your fingers, finally leaving the metal block. Make the entire device positively and negatively balanced. No more repulsion. The pointer is reset. This time through the movement of the pointer, we can intuitively make electrons visible. The pointer moved. This means that electrons are leaving the metal. So at the end of the 19th century, the photoelectric effect discovered by scientists is this. When holding a large flashlight and shining it on a piece of metal, when you increase the brightness of the light, 1 gear, 2 gears, the third gear is so bright that it dazzles the eyes. No matter how strong the light is, the pointer never moved. This means that no electrons leave the metal surface. The photoelectric effect didn't happen, but when changing to a light source with a relatively high frequency. For example, using ultraviolet light, electrons have left the metal. This is on the solar panel, the photoelectric effect that occurs. The experiment is actually not finished yet. If you reduce the intensity of UV rays, no matter how weak, the pointers will move. There will still be electrons running out. It's just that the moving speed will be slower. In summary, the phenomenon of photoelectric phenomena tells us whether electrons can be generated or not has nothing to do with whether the light shines or not. It depends on what frequency of light you use to hit. This stumped all the scientists. For almost 20 years, no one's been able to figure it out, because this was the understanding at that time. Electromagnetic waves are continuous. Energy is continuous. If you keep shining a metal block, energy is continuously injected into the metal block. So as the electrons continue to absorb this energy, it will become active. Think about it. You are very energetic. When you are excited, can you sit still? You can sit still. This is how you want to move active electrons. When it is excited to a certain extent, it will break away from the metal and escape. So this is what confuses scientists. I increase the brightness. Doesn't it mean there are more electromagnetic waves? Doesn't it mean? Is there more energy injected into the metal surface? Electron absorption. So much energy. It should be more active. It should have escaped. The photoelectric effect should be related to light intensity. In 1905, Einstein stood up. Everyone got it wrong. The photoelectric effect is not like this. The energy of electromagnetic waves is not continuous. Have you forgotten what happened 5 years ago? Planck proposed that electromagnetic wave energy is divided into parts. Only his formula can solve the UV catastrophe. This must mean something. This clue tells us bits of energy. In fact, it represents energy packets and energy blocks. In other words, light is actually made up of these small packages. Light is actually a particle. Einstein further explained. How much energy do these little bags have? Only related to the frequency of light. Low frequency light buzzes. The energy of a single package is small, equivalent to a thin person. And the light with high frequency buzzes. It has a lot of energy in a single package, equivalent to a fat man. When you increase the light intensity, in fact, it is equivalent to increasing the number of packages. Too many, the light becomes brighter. The process of photoelectric effect. You probably understand it as many shiny bags hit the metal, and the electrons in the metal block. Like a big fat guy sitting in a library seat. Very solid. Then one by one, the skinny guys have to take turns to challenge. Try to pull the big fat guy out of his seat. Einstein explained. The characteristics of this process are skinny people can pull bags together, but take turns one by one. So no matter how to increase the intensity of light, how many thin people should I let try? None of them have enough strength. The fat guy just can't move, just no response. So there is no photoelectric effect. And the fat man energy pack with higher frequency. Even if you reduce the intensity, reduce the number of energy packs. But every fat man has enough strength. Put an electron, pull away. So no matter how weak the light is, it doesn't matter whether you are weak or not. As long as the frequency of the light you use is high enough, a single bag is enough strength. Pull out an electron, so light with high frequency. No matter strong or weak, we can always see the photoelectric effect. In summary, from the perspective that electromagnetic wave energy is continuous, can't explain the photoelectric effect. Einstein's energy is discontinuous. An energy news perspective explains the photoelectric effect. The above is a toddler version of Einstein's 1905 explanation. The concept proposed by Planck is 1 part energy to parts energy, 3 parts energy for parts energy. Be a bit more difficult to pronounce. To speak is a quantum of energy. 2 quantum energy, 3 quantum energy for quantum energy. And Einstein was inspired by it. It is through such energy characteristics that deduce the particle nature of light, explains the practical significance of quantum. That is an energy pack. Light is composed of quantum units like this. The size of the energy pack. It will be different due to different frequencies. Some energy units are smaller. It's a slim bag. Some energy units are larger. It's a muscular man bag. Available in various sizes. He also gave all the bags names. Quantum of light. Photon for short. That's all. By solving the UV catastrophe and the photoelectric effect, 2 big guys pushed the concept of quantum into the world of physics. They also won the Nobel Prize in Physics. These findings are very sensational. You must know that in the physical environment of nearly 100 years at that time, wave nature of light, it has been proven both experimentally and theoretically. Then the problem comes again. Is light a wave or a particle? Thomas Young's double-slit experiment in 1807. Probably when a beam of light passes through 2 small slits, there will be multiple light and dark stripes at the back. And this stripe proves that light is a wave, instead of particles. Next, let's decipher how it was formed. According to the wave theory, the characteristics of light when it travels are like waves on the water. Puff, 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 like this. What to know here? The wavy lines we are accustomed to are test charts. Up and down. Then the part where the wave reaches the top. We call it the peak of the wave. Slide to the bottom. We call it the valley of the waves. Another way to draw is a top view. Trace the peaks of the waves. What is concave between the lines is the valley. We see it every day, just don't realize it. Sound waves like sound. Wi-Fi signal grid number. The 3-bar signal represents triple electromagnetic waves. It can shock your phone. Then when the wave passes through the 2 slits, 2 waves will be formed at the seam. Then the 2 waves will collide. For example, this animation shows. Very intuitive. So in the middle collision zone, you can see very beautiful textures. Let's identify it. Can you see this raised place? This is the peak of the wave. There is also a concave one. This is the valley of waves, concave or convex. Up and down. This is the oscillation of the wave. It's very narrow, as is the case elsewhere. Up and down, raised up, concave. So these are the two waves in the collision area, the very narrow waves produced. And between narrow waves, there is another rule like this. The situation here is, a wave of wind hit the trough of another wave, and peaks and valleys meet, one on top, one down. At the moment of collision, will cancel each other out. The result is flat land without any undulations. This is the case all along this line. So there are no ups and downs along this straight line. Calm and calm. Please take a closer look at this grid. Simulated two-wave collision. Those narrow oscillations are easy to recognize. There are places with no ups and downs in between. You need to identify it a little bit. The above is the collision area between the two waves. The pattern of texture produced when I shine a beam of light into two slits. Light is like a wave passing through two slits. There will be a collision between the two groups at the seam. They show such a pattern. Keep moving forward and oscillate out. Such a narrow wave. It means there is oscillation in that direction. Specifically, it is the oscillation of light waves. So it's bright there. And in these linear directions, it's all flat land with no ups and downs. It means there is no oscillation of light waves there. So it's dark there. So there's a pattern of alternating light and dark. And because the middle of the two waves collides with the greatest force, the intensity goes to the edge. The smaller it is, so the oscillation amplitude in the middle is the largest. The light bar is the brightest. The further to the edge, the darker it becomes. That's how we get the dark and light stripes we see. In physical terms, the collision of two waves is called interference. Disturb each other. You interfere with me. I interfere with you. The fringes formed after interference are called interference fringes. This is in quantum mechanics. Very iconic proper nouns. However, interference fringes cannot be explained by particle models without outside circumstances. Particles do not change direction on their own. Suddenly hit the middle. This does not conform to the laws of particle motion. So in Benoit's experiment, if light is a particle, two spots of light can be seen at the beginning, and no matter how far I pull the candy bar, I should always see two spots of light. But the actual situation is not like this. At first, the interference phenomenon of light waves was not obvious. It's too weak for us to detect with the naked eye. When I pull the cardboard further away, after sufficient interference of light waves, light and dark stripes appear. Conclusion: light is a wave. Sir Proc. Such an experiment was also shown. He didn't use visible light. It's an electromagnetic wave with a wavelength of 1 centimeter. Shoot out from the right, go through two slits. Then he went sideways to detect electromagnetic waves. Interference bars were detected. Finally, a little brainless discussion. The wave-particle debate on light. It started as early as Newton's time. Newton believed that light was a particle. At the same time, some Huygens believed that light is a wave. Both views can explain some optical phenomena. Particle energy refraction, reflection. Waves can also be refracted and reflected. Who is right? Since then, the two theories have been equivalent. Until Thomas Young's intervention clause of 1807. Maxwell's electromagnetic wave theory in 1864. Hertz's detection of electromagnetic waves in 1886. He clung to the conclusion that light is a wave. On the blackboard, we have proven that light is a wave. Throughout that whole century, this has become the absolute truth defaulted by the mainstream of the scientific community. In 1900, Planck proposed the quantum hypothesis. It didn't cause much commotion at that time. It's Einstein's 1905 article on the photoelectric effect. Through rigorous calculation, proved to the world that light is a particle. This is the basis. What we know about light in 1905. Being led into a new predicament. And a new beginning. The question that has been settled was moved back to the state of history. Light up the world. What exactly is it? An experiment proved that light is a wave. You can't explain it using particles. But another experiment proved that light is a particle. You can't explain it with waves. Rational reasoning tells us a reality that we have to accept. Light is a wave. It is also a particle. This is the wave-particle duality of light. But a substance. How can you have two properties at the same time? Beyond waves and particles, is there any deeper form of existence in space? What is it that the sun shines on? 72-year-old Einstein once said, "What exactly is light?" I've been thinking about it for 50 years. I never felt close to the truth. If anyone claims to have found the answer, then he must be daydreaming. For a while, physicists couldn't understand such a new conclusion. The impact on their cognition is unprecedented. What kind of cognitive shock? Here we have to cover some more. The relationship between subjective cognition and objective existence. When we say that light is a particle, does not mean that in this natural world. Objectively speaking, its essence is particles. It's just that the human species thinks it's a particle. Think of it as a particle, because such a model is very accurate and close to. When we say that light is a wave, it's just our subjective wave model to describe it, to describe our understanding of it. It doesn't mean that's what objective polishing is all about. We have always been able to understand that light is a particle, can also understand that light is a wave. But in the new understanding of the 20th century, we cannot understand the reality that light is both a wave and a particle, because this is different from our usual logical thinking. Sensory experiences conflict, but wave-particle duality appears again, and was observed by us. This indicates that, in objective reality, we found something, this kind of content, beyond human current logical thinking, comprehensive scope. The current physical system is running out of words. We cannot imagine a concept. Let's describe how to deal with this content. This indicates we can only construct a new logic, new thinking, to describe and understand the new content of objective existence. Speaking of which, we have highlighted the historical contributions of the two pioneers. In an era when it has been completely proven that light is a wave, Planck, Einstein successively broke through the original physical system, discovered conclusive evidence that light is a particle, and the resulting cognitive conflict led more scientists to follow their footsteps, to explore the inspiration brought by wave-particle duality. In the process of laying brick by brick, under the mutual comments of many great scientists, these representatives of humanity, adhering to the spirit of pursuing truth, spend a lifetime just to promote human civilization, continuously improve the realm of cognition. At the beginning of the 20th century, they brought about a revolution in the history of science and constructed a new paradigm, a new information matrix, a completely new description system to re-describe the physical laws of this world. This is the quantum mechanics of the future. It all started when Planck wiped away the dark cloud and the Newtonian mechanical system that he has been accustomed to, later known as classical mechanics. Us in the 21st century, we all live in this cognitive system. You push someone else, you will fall too. The effects of forces are mutual. Even if you brake suddenly, you will still lean forward. That's because the inertial celestial body moves and has gravity, etc. There are also some cognitive systems that are religious. Different people in the world, they are all using different perspectives to know this unique world. And to this day, quantum systems are still under construction. So, in the early 20th century, how this new scientific matrix was forged. What new rules did he discover? Classical mechanics. What different angles were used? Third chapter. I will try to bring you into this matrix. At the beginning of the 2nd century, when studying light, we realized that we subjectively thought that light was a wave. As a result, it exhibits particle properties. This inspired everyone to think, hey, the matter we thought was a particle. For example, electronics. We subjectively think that electrons look like this. It's a particle spinning rapidly around the nucleus of an atom. Be aware that this is a derived description model. We think of it as a particle, but no one has actually seen electronics. Is it possible electrons are actually waves? Electrons are actually waves. It's just that we haven't discovered it yet. Or, our understanding of matter haven't reached a deeper level yet. So if electrons are waves, what kind of cognitive problems will it bring to us? Electrons that are both waves and particles shine a light, go through two small slits. On the rear receiving board, there will be light and dark stripes. This proves that light is a wave, because only the interference of waves. Only then will there be such a pattern of light and dark. Particles cannot be produced. Then now, scientists replace the light source with electrons. Launch gun. Shoot the electrons forward one by one. The electrons will either be blocked by the middle partition. Either it will go through seam number 1 or seam number 2. Pay attention here. Electrons are very, very small. Very, very high speed. We can't see it with our naked eyes. Therefore, in the absence of special instrument monitoring, electrons from exiting the chamber to arriving at the receiving plate. In the middle distance, we don't know where it is. I don't know how it got through the double slit, but it is not difficult for us to predict. Are electrons particles? Let's shoot them one by one. On the receiving board, they will be concentrated into areas corresponding to the two slits it passes through. However, this is not the case. At the beginning, you can see the sporadic distribution of electrons on the receiving plate, landing one by one. But as the number increases, the pattern appears. Electrons appear to be selective. Avoided some places, then hit some more places. Eventually, a pattern of light and dark was formed. This is strange. Electrons pass through two slits. Why are there so many stripes? Did he turn a corner in the picture? Take a closer look. This is a bit like the interference fringes of waves. Are electrons waves? Sawing the second experiment. Scientists placed a detector at each seam. One monitors seam no 1. One monitors seam number 2. To track it out from the cracks. Electronics coming. I want to see if you are peeling or particle. But we tracked. After the electrons are really punched out one by one. The confirmed results are even stranger. The interference fringes disappeared. Instead, what we originally expected, 2 stripes. In summary, this has happened over the past 100 years. Very iconic in quantum mechanics experiments. Double slit experiment of electrons. Without detector, interference fringes will appear behind. And in the case of detectors, no interference fringes at the rear. In this way, the variables of the experimental results seem to be detectors. Will the presence of the detector change the experimental results? Did I know that I was being tracked when I hit data electronics? So have you changed your behavior? This is a very strange phenomenon. From a traditional physical perspective, this is incomprehensible. Next, let me sort out one of the mainstream explanations for you. Let us come to the uncertain superposition state of the second byte. The rest of the content will be very abstract. There are a lot of things to pave the way for. But when you get to the last subsection, everything will suddenly become brighter. So what's the explanation for this phenomenon? Probably electrons can be described as particles. It can also be described as a wave. Then when the electron hits the double slit, it's like light waves. 2 waves will form at the seam, continue to spread forward. Those 2 waves interfere with each other. The interference fringes appear. First experiment explained. But if we look at it from the perspective of an example, here comes a strange problem. The first thing I hit was an electron. Then when passing through the seam, a strange scene occurred. The substance electron appears in slit number 1. Also appeared in seam no 2, but I only shot 1. Do electrons exist into slits at the same time? Did it split into? How to explain this problem? The second electron is on the receiving plate. It was punched out one by one. How exactly does it produce interference fringes? In response to these 2 questions, we need to combine the second experiment to answer. So in quantum theory, it has a very unusual description logic. This is when you need to switch your thinking. Quantum theory discusses more than just conventional physics. It involves high dimensions, involving the question of what is reality. For example, the matter we see explains a reality. Visible, touchable, and sensible. Then how did the reality I see now appear? How does it exist? It has risen to this dimension. And things like electronics. It's not like a small ball. We can see it any time. We don't know what this matter really looks like. Then the whole process in between. We can't see it. I don't know what the structure of electrons is either. What's the state of affairs? So when we shoot electrons into the double slits, mathematics tells us it is a wave. The meaning of this wave is the range covered by the wave. These are all places where electrons appear. This will be possible and possible. It can appear in 1, can also appear in 2. This is where it can appear. But where exactly? Don't know, not sure. How to describe this state of uncertainty? Use probability to have a probability of appearing. There is also a probability of appearing in 2. So what causes this uncertainty? In the description of quantum theory, here comes the most fundamental key point. It says that not only subjectively, we don't know which seam the electrons are in. And objectively speaking, where is the electron? This reality has not yet emerged. Hasn't happened yet. This is what quantum theory describes. The rules so. It takes everything that hasn't happened yet. But the possible events add up. The total number is superposition. So in the physical world he defined. At this moment, the electron is in this superposition state. The above is the first concept. It doesn't matter if you can't figure it out. We need to use the 23rd concept to enhance understanding of it. Measure and explore. Then in the second experiment, when we have a detector, when electronic location is tracked, we found it at seam number 2. It's at this time. Only then can we be sure that the electron is at seam number 2. This happened 100. It's on seam number 2. Then according to the description of quantum theory, it will say at this moment, the superposition state of electrons from the beginning collapsed to a specific state. When did the collapse occur? It is the detector that measures the position of the electrons. Moment, according to quantum theory. This kind of external measurement intervention will cause the superposition state to collapse to a certain state in the distance. That is, the exact location of the electron at the beginning is not yet known. Once the electron is measured by the outside world, the superposition state collapses. The reality of where the electrons are is revealed. It's on seam number 2, finally. Let's practice this new logic while it's hot. Is mother at home? For example, I'm not sure whether my mother is at home or not. She might be at home, maybe not at home. According to the description of the new logic, MOM was in a combination of these two states. Then I opened the door and took a look. At the moment I observed, the superposition collapsed immediately. Collapsed to the state where she was at home. You must have a question at this time. In fact, is mother at home? Isn't it something that has been determined? Isn't this reality? Has it already happened? For example, she was already at home. It's just that I don't know. So now I guess there is a chance that she is at home. There is also a chance that he is not at home. Then I go home and take a look. She is here, so my original guess turned into a certainty. I'm sure MOM is at home. Look, look. The whole process, MOM is actually at home. It's just that I don't know. Isn't it? This is what our senses perceive. The world we see with our naked eyes is like this. And I use the example of my mother, just to make it easier for everyone to compare. The difference between the two narratives. The subjective cognitive process is exactly the same. The difference is in the description of objective reality. Can everyone sort it out clearly? Now let me rephrase it in other words. There are objective differences between the two description logics. There is no subjective difference. Does that mean? Assume that objectively things are indeed described from a quantum perspective. Happened but we subjectively. Have you never noticed it? Everyone taste it carefully. Of course, you don't need to accept this new logic, as long as you know the difference. So with this new logic, we can explain this experiment clearly in one breath. When an electron is punched out and passes through the double slits, it behaves like a wave. The range covered by the wave is where it will appear. Maybe in a seam, maybe in the second seam. Objectively, the electron is in this superposition state. Once it's at the seam, probe it. The electrons go from a superposition state to a wave state. Collapse to a specific location. The state of a particle is discovered by us. Then, The particles hit the receiving plate in a straight line. So before being detected, the electrons have been in an unknown superposition state. We cannot see this substance. Only at the moment of observing it, it collapses to a specific particle state. So it shows we detected one electron after another punch out from seam number 1 or seam number 2 and falls on the receiving board, form to stripes. Then the first experiment can also be explained. An electron is punched out. When encountering two seams, it will form two waves at the seam like a wave. After the two waves collide, a beautiful collision pattern will be formed in the middle. Among them, bright stripes. It's because there are oscillations of light waves in that straight line direction. That is to say, that is where the light exists. That's why we can see bright stripes. Same reason. The result of the interference of the two waves is alternating light and dark stripes. These bright fringes after interference represents the oscillation of the wave with electrons in that direction. It means that is where the electrons exist. So at this moment, 1, 2, 3, 4, 5 stripes are where electrons appear. Where exactly? I don't know subjectively. Objectively speaking, it has not appeared yet. It is in a superposition state of article 1, 2, 3, 4, 5 at the same time. The receiving board is actually a detector, because we have to use instruments to measure. After electrons travel to this distance, where exactly is it? According to the description of quantum theory, once there is external measurement and observation behavior, the electron superposition state collapses to a specific state. Then we detected it. The next electron hits. The electron is in a wave state. Two waves interfere with each other. These stripes are all candidate landing sites for it. Two waves collide with each other, dark stripes. It's because there is no wave oscillation in that direction. So back to this example. After two waves of interference, oscillation of waves without electrons at dark stripes means that these are not places where electrons exist. So the electrons won't collapse here. In this way, it finally appears. Electrons hit certain places selectively. Then I avoided some places and produced interference fringes. This illustrates the wave nature of electrons. The above is based on quantum theory, one of the mainstream explanations for the double slit experiment. Then the two questions raised earlier can also be answered. The concept of simultaneous existence is called superposition state. How do electrons create interference fringes? That is the collapse process of the superposition state. It is enough to understand this level. Finally, let us summarize. Wave-particle duality of light in the early 20th century. The inspiration for people is the light we thought was a wave. There is also a particle side. Then the matter that we think of as particles. Does it have a wave side? Then we developed the concept of wave-particle duality in everything. And one of the biggest features of this new content is the wave function, Schrodinger's wave function equation. It uses waves to describe objective matter. For example, if we use waves to describe electrons, it involves superposition state, new descriptions of measurement and collapse. This phenomenon is not yet seen in our daily lives, but this kind of weird phenomenon. But it can be observed at the molecular and atomic level. So this big piece of new content, if we trace the source, who can it case? This is what we talked about in chapter 2, Planck's quantum and Einstein's light. Quantum is the beginning caused by the two of them. So in order to distinguish it from Newtonian mechanics, any new theory related to this series of chain reactions, Hooke concept, scientists added a prefix. That's quantum superposition. At the prefix quantum superposition state, collapse is prefixed with quantum collapse. Other concepts, such as entanglement, quantum sutuan. So far, the quantum unit of energy is developed a second meaning. It represents a broader, includes all concepts within this physical system. The symbol of this system is wave. Treat matter in terms of probabilities. What about Newton said was given a new name, called classic? Our daily routine is classic. Any new theory, you will definitely face various challenges and doubts. Take the superposition state as an example. I have always stressed that this is a mainstream explanation, because it doesn't convince everyone. If the superposition state holds, then the question comes, well, since electrons are one of the particles that make up human beings, then when people pass through two doors, why does it not exhibit wave properties? Two doors at the same time. Ah, it feels like a parallel universe. At this moment, Schrodinger's cat is about to make its debut. What is this cat doing, and this Schrodinger's cat? It is the development of quantum mechanics, a very classic thought experiment. What on earth did this cat do? Superposition state. So, is that exactly what happened? We actually don't know. That's just what math tells us. And when the position of the electron is measured, this superimposed reality will instantly collapse into a single reality, observed by us. And this is the reality that we can see, feel, and touch. The above is a very novel, explanatory logic for objective things. It is based on the research perspectives of Bohr, Heisenberg, and others. Because their research location is Copenhagen, the capital of Denmark. So this interpretation is also called the Copenhagen interpretation. In Nolan's film Oppenheimer, describing the words of Bohr and Heisenberg, then I believe that after seeing the superposition state observation and measurement, reality collapses, you will find it incredible. This is a bit ridiculous, and in that era, proposed wave function equation in the same field. Schrodinger has long publicly expressed his skepticism that he also had the support of Einstein. The red side's view is that physics research done by Green Square, your theory. It smells a bit like practicing metaphysics. And the red side, on behalf of Schrodinger, I used a cat thought experiment at the beginning. The problem of the green side is pointed out sharply. The experimental settings are as follows. In a big box, there is a special device. There is some radioactive material in it. Then the radioactive material undergoes decay. This is a natural and spontaneous process. You probably understand it as, after some time, the substance will spontaneously emit an example. But it is unpredictable when it will decay. Schrodinger then hypothesized that in an hour's time, the radioactive material has a 50% probability of decaying. There is also a 50% probability that it will not decay. Then there is a detector next to it. When a detector detects decay, it will trigger a hammer. Break a bottle containing poisonous liquid. Bottle broken, the venom will evaporate. At this time, there is a cat in the box. Then if the venom evaporates, will randomly cause the cat's death. The above is the experimental equipment and settings. That's how Schrodinger challenged it in the first place. Okay, according to the definition from the legal point of view, the nucleus is an independent system. After 1 hour, decay without being observed. The reality of no decay has not yet emerged. That is to say, two realities exist simultaneously, superimposed together. So now imagine, if matter decays, the detector will start. Trigger the hammer to smash down. The bottle will break, the venom will evaporate. This will eventually lead to the death of the cat. If matter does not deceive, the detector was not triggered. The hammer didn't move, the bottle is not broken. The cat is not dead. So this series of event arrows has a proper name, called entanglement. You simply understand that you are involved in this chain of events. So here's the neat thing about this experiment. Schrodinger, linking microtheory and macro phenomena, he said, according to the legal perspective, this is called a superposition state. But if your superposition state description model is established through chain reaction, so it will cause a living animal to appear in the box. Macro cat that also died. I doubt the situation. Schrodinger put the cat in the box, then put the lid on. If the superposition state of microscopic matter, if this description is true, after 1 hour, chain reaction through series, before I open the box, the cat in the box will be dead. A superposition state that is also alive. Schrodinger said, this is simply ridiculous. Obviously not consistent with the facts. Schrodinger believed there are only two situations for the cat in the box. Either alive, either dead. Reality only develops in one direction. How can a superposition reality exist? What does the direction of reality have to do with my observation or not? Also, how do you define this observation? For example, It is a complex experimental instrument that detects the position of electrons. Experimental instruments are unconscious. Is an objective substance. So here comes the question. Is an objective measurement? Or is it the observation of human subjective consciousness? Did it lead to reality exploration? That is to say, Copenhagen explained, there are so many questions that need to be answered. And Schrodinger's cat is the most concise expression of doubts about it. But precisely because of his liveliness and conciseness, I fell into. He is more often used as an example of the green side, to illustrate the green's point of view. So until today, all cat problems, not thoroughly explained. Just talk about the theories of quantum mechanics. How does it relate to the macroscopic phenomena we see? Connected to the macro world, and in 1957, American physicist Hugh Everett. I tried to find another way, solving cat problems. That's the multiverse. Explanation. Let's come to the last section. You in another universe. He said, the moment you open the box, you'll be able to see the box. You'll be able to see the box. He said, the moment you open the box. Maybe the superimposed reality didn't collapse at all, but divided the moment it opens. There's a cat you saw alive. This you got entangled with this real cat. At the same time, there was another one where you saw the cat died. You are entangled in this reality. The superimposed reality develops into directions. So his logic. It's not like you live in a single reality. It's that you are entangled in a certain reality. So this bifurcation process. There is a term called decoherence. You roughly understand it as the superimposed reality has its space-timelines bifurcated. According to his explanation, from the moment of decoherence between two realities, no more information can be exchanged with each other. That is to say, we are beings living in one of these realities. But what about? No information about another reality can be obtained. Every time something has a different direction, different results. The most intuitive manifestation is choice. Reality will push forward. Follow this logic. You can get one of the views of the multiverse. That is in this time and space. There are countless parallel universes, developing in different directions. There is a movie called Coherence. The setting is based on this concept. The story begins like this. At a party, there was a sudden power outage. So the main characters plan to go out and have a look, then install the red one separately, and a package of blue glow sticks. Everyone chose to use blue fluorescent sticks for lighting. At this time, a pushing sensation has already occurred, because another reality of the superposition state is. The protagonists chose to use red glow sticks. But the movie doesn't tell us this. Then 4 of the protagonists walked outside the house. Go watch the comet streak across the night sky. The settings are like this. This comet event will make the decoherent world coherent again, so that they can interact with each other. And this related coherence. That's the original title of this movie. 2 worlds intersect. So this is what happened. The protagonists meet for identical, another me. The one holding in his hand is a red fluorescent stick. So in the movie, and the details of the ocean, all show different parallel universes, related situations. The audience needs to distinguish for themselves. People from this world have gone to that world. People from that world came here. The content is complex, and according to the director's own statement, theoretically, there are countless worlds. But in the movie, he has less control. A total of 5 worlds are displayed before and after. This movie is very intriguing. Compare the 2 explanations. Copenhagen's superposition collapses, so we can only see one reality. The superposition state of the multiverse will decohere. After decoherence, the world can no longer communicate with each other, so we can only see one reality. 2 descriptions. Only logically understand the past of the person. Of course, there are also many unresolved practical problems. I won't go into details. Let's go back to the original question. What is quantum mechanics? As of now, we talk about the microscopic world and look at quantum. Macroscopic view of classics. These are 2 different description systems. But a world, how could it be based on 2 sets of physical laws? That's it. Every physical theory wants to reach the highest level. It's unified physics. Take all objective concerns in the world, all included in his scope. Everything in quantum mechanics has strict binomial properties. Not just particulate matter can be represented by peeling. All macroscopic substances also have the property of peeling. The wavelength of radio waves is 10 meters. The wavelength of visible light is between 360830 nanometers. The wavelength of gamma rays is below 0.1 nanometers. The electronic wavelength is also within this range. You can probably imagine, the shorter the wave, the narrower and more crowded it becomes. It's so small that it's so crowded that it's almost connected, and calculated according to the matter wave formula. A baseball with a mass of 0.2 kilogram. Its wavelength is at the level of 10 to the power of 25 nanometers. Just say that the bigger the object is, the smaller its wavelength to the macro level. It is so small that it can be ignored. Follow this logic. Newtonian mechanics is a special case of quantum theory, because Newton summarized the laws of mechanics. The descriptions are all small ball objects, collision between objects, the laws of motion of such macroscopic objects. First, he couldn't consider the nature of waves. Secondly, he does not consider or affect the accuracy of the formula. After all, at this level, the nature of the wave itself cannot be observed, so it doesn't matter if you don't consider it. But when is Newton's work inaccurate? That is when objects become smaller and smaller. For example, the electron wavelength is 0.1 nanometers. This is the same as the size of the electron itself, already at the same level. The impact of wave properties cannot be ignored. The atomic model in our textbook. They are all simulations of classical mechanics, and according to quantum mechanics, the atomic structure is more complex and delicate this way, and ever-changing. But even at the microscopic level, quantum mechanics provides a more detailed description, discovered more patterns and phenomena. But until today, it's always working hard, looking for a bridge to connect with classical mechanics. This includes how to confirm the observation of quantum phenomena at the macroscopic level. Let's do a brief ideological reasoning again. Everyone is familiar with the theory of plate motion. Roughly means the continental plates actually move, but every year he only moves 1.5 centimeters. Please make a gesture with your hands. Converted. That is to say, in fact, the continent is moving every second. Only move 10 to the power of 10, you imagine. He only moves a little bit every second. For someone who is 1.7 meters tall, the effect of this exercise is too small. So small that we can't even observe it. Its movement effect disappears. But if you are small, down to the microscopic level of atoms, the effect of this exercise is very obvious. The continent is in motion. This is the size of the object, the difference in perception caused by. In the Marvel Ant-Man movies, this effect is very vivid, so only based on theoretical reasoning. If a person wants to pass through double slits like an electron, is divided into two, the theoretical width of the gap that a person needs to pass through, approximately equal to the wavelength width of a human being. The starting point of 10 to the power of 30. So who can do it? Still people-oriented. So in the setting of the movie, Ant-Man wants to shrink his body infinitely. Find quantum tunnels this way. Access to a past world or another resource. In summary, as long as you think enough, you can observe, at macro level, what is not observed. In this way, people go to explore objects from small to large. When exactly did this kind of microscopic quantum phenomenon occur? Disappeared for what reason? Is it possible that it has not disappeared? It's just that we haven't been able to observe it yet. The above is the development of quantum mechanics to the present stage. One of the big problems facing. Okay, after the explanation, we have a very basic understanding of quantum concepts. I believe that when I go online in the future, you won't be too unfamiliar with this vocabulary. You can also understand, in the history of physics, after Planck wiped away Kelvin's dark cloud, started the development of quantum mechanics. If you gain something, please don't forget to like it.